Welcome to the wonderful world of radiant floors. The basic idea of using warm water to distribute heat dates as far back as the Roman era. However, it was the development of PEX distribution tubing that unleashed the concept's vast potential. More and more homebuyers are willing to invest in features designed to increase the level of comfort in their homes. The advantages of in-floor radiant heat systems add up fast. Energy and savings, quiet operation, and a dust-free home are three very important features. The most important feature is total comfort. This video will show you the steps used to properly install an in-floor radiant heat system. We will take you through the design phase, showing you how a heat loss is created and how equipment is chosen for a project. We'll show you the different tube layouts used in a radiant heat system. We'll show you a boiler room setup and various control strategies. Lastly, we will explain the importance of purging a system properly, discussing the use of propylene glycol and water treatment. Radiant floor heating systems in residential installations are capable of delivering 25 to 40 BTUs per square foot. Pay special attention to areas with potential for high heat loss. Windows, doors, and other areas of high heat loss require closer spacing of in-floor tubing. Spacing is normally extended 3 feet into the room. Since radiant heat systems warm objects and not the air, the infiltration losses are minimized. To determine the amount of heat required to provide comfort in a room or a house, it is necessary to calculate the amount of heat lost according to the coldest day. A room-by-room analysis must be done to ensure the proper radiant design. The heat loss from an area must be replaced by heat from the floor. Do not include cabinet areas or other areas that do not generate heat. It is very important to provide the program accurate room measurements to assure the proper tube size. Floor coverings have a pronounced effect on the performance of radiant floors due to their insulating qualities. A floor covering with high insulating properties, such as carpet and pad, needs a hotter supply water temperature to achieve the required floor output. Tube spacing and total tube length required varies according to BTUs needed to heat any given area. 1/2 inch diameter tubing at 9-inch spacing can provide more BTUs than 3/8 inch diameter tubing at 6-inch spacing. The tube size is calculated automatically on the MaxCalc program according to the specifications input into the program. A complete tubing layout is not necessary. It's only necessary to provide manifold locations, number and length of loops, and tube spacing. The layout can be done in the field. There are various types of boilers or hot water sources that can provide adequate hot water consistently to operate an in-floor radiant heat system. Water heaters are used in some systems, but are not enough for most applications. Heat sources include cast iron, copper finned, steel, and ground source heat pumps. Each heat source has its benefits. Find the one that best suits the needs of your particular project and budget. When you choose a hot water heat system, there are various uses for the system. An abundance of domestic hot water can be provided using an indirect tank. This water heater is basically a heat exchanger that provides domestic hot water using the boiler's 180-degree water as its heat source. A snow melt system is another application of hot water heat. These systems are used for driveways, sidewalks, and parking lots. Radiant baseboard and old-style radiators are other distribution methods. Once your heat loss has been calculated by a trained radiant heat designer, you can be confident that your upcoming project will be successful and you will have the most efficient and comfortable heat available. It is important to install a ground insulation as well as an insulation along the edge of the slab. This prevents a great amount of heat loss into the ground or out through the edge. What is typically used is a 2-inch polystyrene insulation board. Place your edge insulation on the inside or the outside of your foundation wall. Make sure you use enough insulation to cover the entire edge. Before you place your ground insulation, begin with a flat, level ground surface. Begin setting the insulation board. It is also a good idea to duct tape all seams to prevent any gaps. Make sure the entire slab area is covered with insulation. After insulation has been put in place, lay reinforcing mesh over the insulation. The adjoining sections should overlap and be securely fastened together. Now that we've put our insulation down and have our wire mesh in place, it's time to start laying tubing. We first check our design sheet. That will tell us what size of tubing, tube spacing, and loop length is to be used in this particular area. All in-floor tubing should be 6 inches away from walls and cabinets. Do not place tubes in areas where equipment will be bolted to the floor. Do not make bends tighter than 6 inches for 3/8 inch tube or 9 inches for 1/2 inch tube. Most tubing has foot markings on it so that it can be installed without actually measuring its length. There are typically 2 types of tube layout patterns: counterflow spiral and the serpentine pattern. The counterflow provides the most even distribution of heat. The supply and return lines run next to each other, creating a more even temperature between the tubes. The counterflow spiral is the more difficult of the 2 patterns to install. The serpentine pattern is used when most heat loss occurs along a wall. The water temperature decreases as it flows through the tube. This layout is used when hotter water needs to be concentrated in areas of high heat loss. The serpentine pattern is the most common method of installation. Once it's been decided which pattern type to use, find the area best suited for your remote manifold. It should be as centrally located as possible and easily accessible. Cut the end of the tube clean. Fasten it down at the base of the manifold location, leaving 3 to 5 feet of excess tubing. Use nylon ties to secure tubing directly onto the wire mesh. Unroll the tubing by hand or use an uncoiler, and fasten tubing down every foot. Keep track of your tube loop length. 3/8 inch tubing should not exceed 200 feet, and 1/2 inch tubing should not exceed 300 feet, plus or minus 10%. Once you've completed your first loop, it's important to mark each tube and distinguish each loop to avoid confusion once all loops have been installed. When all tubing is installed and tied down, we can determine how many loops are required. We now connect tubing to the manifolds. Most manifolds can be installed in a wall cavity or surface mounted. It's recommended to place manifolds a minimum of 3 feet above the finished floor level. Use an in-floor tube cutter to guarantee a straight, clean cut. Connect tubing with compression adapters. Place the brass nut with the compression ferrule on the tubing. Tighten the nut. Then push the fitting into the manifold. Crimp fittings can also be used in place of compression adapters. Once all tubing has been connected to the manifold, it is very important to pressure test the tube. This is done by installing a temporary air pressure device and pressurizing the system up to 60 psi. Now all we need to do is pour the concrete. When pouring the concrete, care should be taken that the tube is not damaged. It's best that the tubing be raised to the center of the concrete slab pour. This can be done by lifting the wire mesh if necessary. If a leak does exist, it'll be easy to spot. Remember, you have 60 pounds of pressure in that tubing. Once the concrete is leveled and set, your in-floor heat distribution system is complete. It's essential to begin a Stapledown project with a clean working area. All debris should be removed from the area where the tubing is to be located. Before you begin stapling, you should set the pressure of your staple gun. This project will use a pneumatic staple gun. Using a scrap piece of tube, set the gun around 40 pounds of pressure and staple the tube. The staple should hold down the tubing but not kink it. It's okay to leave some gap between the tube and the top of the staple, or a slight indentation. Choosing the proper staple is determined by the size of the tubing you're installing. Most common length of staples are 1 1/4 inch length. The width is determined by what brand staple gun you have. The important thing is to make sure the staple doesn't pull up after being installed and doesn't damage the sides of the tubing. Now that the pressure's been set and staple length has been determined, it's very important to position the staple gun properly. Most staple guns used for in-floor tube applications are equipped with a custom-made guide that will help place the gun on the tube properly. Tube layout options are the same for subfloor applications as they are for slab-on-grade installations. An uncoiler is recommended. It makes the job much easier. Location and installation of the remote manifolds is the same as a slab on grade application. Stapledown applications require the addition of a thermal mass. Thermofloor is a lightweight gypsum-based cement that encapsulates the tubing. Before pouring Thermofloor, the subfloor needs to be cleaned and a primer adhesive applied. To account for the change in floor heights caused by the application of Thermofloor, use a double sill plate. Thermofloor is designed specifically for Infloor radiant heating systems. It encases the tube in a crack-resistant, non-combustible thermal mass. Thermofloor also makes your Infloor heating system more responsive, provides a smooth, tough surface, stiffens the floor, won't shrink or crack, eliminates squeaks, and accepts virtually all floor coverings. Thermofloor is UL listed on over 50 fire-rated assemblies. It produces zero flame, zero fuel, and zero smoke. Thermofloor is only installed by trained applicators. Then, in 2 to 3 hours, you have a wonderful thermal mass hard enough to walk on. In approximately 7 to 10 days, depending on the environmental conditions, Thermofloor is ready for floor coverings. Now that we've shown you the proper way to set up your in-floor distribution system, let's continue with the next major part of your heating system, the heat source. Although there are many types of heat sources that operate in-floor radiant heat systems, the most common is a boiler. Typically, boilers operate at much higher temperatures than are normally required for radiant heating. So it's very important that the proper controls are used to keep both your boiler and your in-floor system safe. When your in-floor heating system was first designed, the boiler type was determined based on location of the boiler room, venting access, and budget. To begin your boiler room setup, set the boiler in place, keeping in mind the clearances required by both local codes and the boiler manufacturer. Make sure an electrical outlet is placed in the boiler area, along with a gas line to supply the boiler with fuel. It's recommended that the boiler be put on its own circuit breaker for maintenance purposes. Next, install a backflow preventer and a fill valve. This supplies the boiler system with water as well as preventing any contamination between boiler and domestic water. When you begin piping from the supply and return side of the boiler, it's a good idea to install ball valves to isolate the boiler from the rest of the system. Most pumps on a boiler come pre-wired and include isolation ball valves. The next thing is to install an air eliminator. This is typically placed on the supply side of the boiler system. An expansion tank comes next and is sometimes attached to the air eliminator. If an indirect water heater is being used, branch off from the supply side of the boiler piping to the supply inlet of the water heater. From the water heater return inlet, go back to the boiler return piping. A zone valve is placed on the supply side piping of the water heater and wired into the aquastat on the tank. Venting material used for your boiler system depends on the type of boiler being installed. Some materials used include PVC pipe, double wall galvanized pipe, or stainless steel pipe. Check your local codes as well as your manufacturer's recommendations on the proper material and installation method. At this point, we have up to 180-degree water. A radiant floor requires a maximum of 140-degree water. It's necessary to provide some way to temper our water going into the radiant floor area. A four-way mixing valve does this job very well. It tempers the water by mixing return water from the floor area with supply water from the boiler. A four-way mixing valve assures proper flows in the radiant floor and the boiler. The mixing valve may be manually adjusted to provide the proper temperature into your in-floor heating area. Temperature gauges are recommended after the four-way valve on both the supply and return side of your manifold to measure exactly the supply and return temperature. It's best to maintain a 20-degree difference, which ensures proper heat distribution. A secondary pump with isolation flanges is placed on the radiant floor side. This provides adequate flow through your in-floor system. Your supply piping goes to each remote manifold supply and returns from your remote manifold to the boiler room return. A zone valve is placed on the return side of your boiler room manifold. This, along with the thermostat, controls the temperature in each particular remote area. This process is continued until all remote manifolds are tied into the boiler room manifold. This completes the piping of your in-floor system. Some local inspectors require you to pressurize your system before filling it with water. It's also a good way to check for leaks. Wiring comes next. Use a control box to help tie in all zone valves, thermostats, and your secondary pump. If using an indirect water heater, some control boxes come with a hot water priority. This makes sure your domestic water needs are always met. A control box provides a neat and centralized installation of your radiant floor control wiring. The control box also connects to your boiler. This completes the wiring of the system. The final phase of your radiant floor system is filling and purging. After doing a complete air pressure test to ensure no leaks exist, use the automatic fill valve to provide water to your heating system. Ball valves on the system should be opened or closed, forcing the water to flow from the supply side to the return side. A boiler drain on the return side of the boiler should remain open until a steady stream of water is flowing. Continue filling the system until the pressure is between 12 and 20 pounds. The most common complaints about hydronic heating systems are usually related to air in the system. It's vital to remove all air from the system to assure proper operation. Air trapped in tubing or manifolds can prevent proper circulation through in-floor tubes. Problems such as accelerated corrosion of equipment, loss of heat output, reduced circulation, and reduced heat transfer by the distribution system are just a few concerns with trapped air. An air eliminator installed in the system will remove any excess air in the closed system. Microbubble air eliminators are the most efficient available. System treatments are not necessary, but recommended as they prolong the life of system components. There are several types of system treatments available. Some are silicate-based, non-chromate treatments. If freeze protection is desired, non-toxic propylene glycol can be added. The amount of glycol used in the system is based on the degree of freeze protection desired. In no case should automotive antifreeze be used in a heating system. Automotive antifreeze can damage system components and it is toxic. An in-floor radiant heat system is the most comfortable heating system available. It's been proven effective and efficient throughout the world. In this video, we've covered design, tube layout, boiler room setup, and purging. These are all the steps in creating a heating system that provides both comfort and efficiency.